Hi, in this video we're going to discuss about redirections. So it's going to give you a sort of overview of redirections, this video and the following ones, and this is going to pretty much help you get into the reading assignment, which are going to offer much more details. Okay, so let's start with the big picture regarding redirection. Redirections are a mechanism that is very interesting, and that is found nowadays on every type of command line interface. It started with Unix, Linux, but even nowadays, like Windows command line interface and whatnot are featuring the same kind of ID. Okay, and sometimes this ID has even been, how to say, developed further to go beyond text-based redirection, which is what we're going to use right now. Redirection of input and output of commands that are pretty much manipulating text mostly, and it has been extended in other operating system and other shells to manipulate all sort of media, all sort of digital information. So let's get started with the big picture. Okay, we have we are going to represent Unix, Linux, whatever, commands and tools as boxes. Okay. So this is, for example, I don't know, this is the sort command that we're going to use in a few examples in this module. Okay. Now, what I want you to picture is when you are on your command line and you use something like sort, okay, and then you enter some data that needs to be sorted, and then sort displays. So this would be the input. Okay, you type sort enter, then you provide as input. Let me show you what I'm talking about here. Type the command sort, okay, then type as input 1, 2, 3, for example, enter at the end of each line, blank line, then I'm going to do Control D to tell sort I'm done typing input, and this is sort producing its output, which is 1, 3, 2, which is the alphabetical order of those 3 lines, okay, actually 4 lines, the blank line has been put first. So you type your input here, and then you see sort. Where's my pen? There we go. You see sort produce output, which is pretty much the ordered version of the input. So what do we have here? We have the input that came actually from, well, let's see, this is our terminal, right? It came from the keyboard. The keyboard produced the input for sort. Sort then produced its output, and this output was displayed actually on the terminal itself, okay? The console that we were using. If there is something that goes wrong with sort, for example, I try to say sort -L. I think -L is not a valid option. There we go. So I try to use an invalid option, and you can see that sort display error message is also in the terminal. So we could add to this little diagram here that our error message from sort, if any, so this is optional, let's say, okay, are also produced on, guess what, the terminal. And what part of the terminal? The actual screen of the terminal, where the text goes, okay? So this is a very nice way to introduce actually the concept of standard input, standard output, and standard error, okay? So what are those things? These are file descriptors, so you are going to learn much more about file descriptors when you take the operating system class, okay? But for now, I'm going to represent them this way. We have an array inside of every process, every program running on our system that is indexed starting at 0, and that represents file descriptors. And it's a way for us to, in a very simplified way of explaining it, it's a way for us to keep track of all the input-output, all the files that we have open at the time, okay? Some of them we are going to read from, some of them we are going to write to. Among all those possible files that are open, the 3 first entries of that table, index 0, 1, and 2, have a very special meaning. 0 is, by default, connected to something called STD, standard, input. Okay, so I'm going to represent it like that. You can view it as, it's like we have a port open on that box, you know, and whatever STDIN is going to feed information, feed a stream of information to my program sort via that port. And then we have 2 other ports that are interesting, number 1 and number 2. Okay, number 1 by default is connected to STDOUT. Guess what? Standard output. Okay, so what is STDOUT? Well, the same way that STDIN generally is, or by default I should say, is actually the keyboard, STDOUT by default is your terminal. Okay, so you see how this is connecting to our first attempt at understanding what's happening when we use sort here. The input would be STDIN, labeled STDIN. The output would be STDOUT. Now there is another descriptor here that I haven't explained yet, descriptor number 2. This one, by default, is connected to something called STDERR, standard error. Okay, and this one is interesting because this is the same thing than STDOUT generally, so it ends up at the same location than STDOUT. It's just another communication channel that will be displayed also on the screen. So here we go, STDERR is there. Okay, keeping in mind this picture of Linux tools, you know, independent commands, processes, more generally even speaking, being those boxes with some channels in and out, and these channels being able to be connected to different things like STDIN, STDOUT, STDERR is going to be very, very useful for you in understanding how redirections work. So let's take a look now at what we have in terms of simple redirections, what we can do with simple redirections. So first thing we're going to talk about is redirecting like so, with a greater than sign, so it's easy to remember what it does. Okay, if you have a command and then you put the greater than sign after that command, that means that you are going to take one of the output of the command. These are my three standard input-output there. I'm going to take one of the output of that command and feed it, you know, the sign looks like an arrow pretty much, feed it to something else. Okay, and we're going to talk about what something else is. In our case, it's going to be a file. For example, let's call it data.txt. Okay, so that first symbol here, like the greater than symbol, allows us to do that. Allows us to specify a command, specify a file, and say that one of the output of that command is going to go into that file. So we know that there are two different types of output, right? There is a STDOUT output, STDERR output. So how do I specify which one I want to dump in the file? It's easy. I can precede this sign by 1 or by 2. Okay, so that means redirect STDOUT to that file, redirect STDERR to that file, and if I do not specify anything, by default it's going to be STDOUT. So I could write it, you know, right here. There we go. This guy and this guy are identical. So let's take an example to see how this is working. I can keep using sort. I can also use something like a command, like echo. You know what echo does, right? It displays a string on the screen. So it's an internal, actually, it's an internal command of the bash shell. It's not an external tool, like an external program, like sort, that the shell runs for us, but it's going to work the same way. Okay, it's going to work the same way for this example. So echo hello world, you see it displays hello world. Well, let's try to play with that. I'm going to use up arrow to recall the last command, and I'm going to say I don't want you to display on the screen. Okay, so in other terms, what I want to do is I want to change, let me take some color here, I want to change this, right? When I do echo hello world, it's still going to send the information to the file descriptor number 1. Okay, by default echo is displaying on that output channel if you want. The only thing is that instead of connecting that output channel to STDOUT, which is my screen, I want to say forget about STDOUT and connect this output channel here instead to a file. Okay, and like I said, I'm going to call that file for now data.txt. Okay, so that's what a redirection is. You do not change the way that the command writes to one of its output ports, okay, in this example, or the way it reads from one of its input ports. But what you are changing is actually the destination to which the port is attached. Instead of being attached to STDOUT, now it is attached to a file, data.txt. So this is exactly what we are going to do, and we are going to use this syntax here to do so. Okay, so we're going to use this first syntax, which is a default syntax, then we are going to use the one greater than syntax, which is completely identical to it. So let's say data.txt is the name of my file, and as you can see, nothing happened on the screen. So when I wrote actually to file descriptor number 1, I didn't write to STDOUT in the sense of I displayed on the default STDOUT, which is a screen, right? I wrote to my file descriptor number 1, which has been redirected toward a file, data.txt. So now I can see that I have here data.txt. Okay, this is a file. This is a non-empty file, and I can look at its content, you know, using cat, and I can see that it's a string hello world. So it worked. Echo redirected the output of my program to a file. Okay. Now, I mentioned that there were equivalent syntaxes. Okay, so echo hello world 1, and I'm going to call this one data1.txt. Okay, there we go. ls, sorry. I can use ls too. data1.txt. There we go. Hello world, and q2 exits the viewer. Okay, so same thing happened here. I can redirect with just greater than, or make sure that I specify explicitly what is the output that I want to redirect. In this case, 1. I want to redirect my STDOUT. Okay. So now the other thing that we talked about was redirecting STDERR. Okay. So first, let's take an example here with sort. Okay, we have sort-l. We know this is an invalid thing. So what happens if I do sort-l, and I'm going to remove those files so that they don't get in our way. Okay, txt. All right. So what happens if I do sort-l and I try to actually redirect this to, I'm going to call it sort.log. Okay, I want to see what happened with my sort command. Well, I redirected the standard output, but nothing went on the standard output. So if I try to do cat sort.log, yes, it has been created, but there's nothing in it. Okay. However, the error has been displayed on the screen. Okay, so let's try the following just before I move on to the meat of this demonstration here. If I would have done obviously this, okay, 1 greater than sort.log, same thing would have happened, exactly the same thing. So I removed the sort.log file, redid the experiment with 1 greater than instead of just greater than, and now the outcome of the experiment is the same. Okay, so obviously this is not helping with redirecting STDERR. And that pretty much makes sense, because I need this syntax here to do so. I need the 2 greater than, okay? So I'm going to try to use that syntax. Sort. Let's be lazy. Sort-l, there we go. And this time I say 2 greater than sort.log. Nothing went on the screen right now, so this is good news. If I do cat sort.log, what do I get? I get the error message. So this illustrates the other thing that commonly is redirected, which is the standard error output. I'm interested in running a command like sort. I know the command is going to display any error message to its second file descriptor, which is connected to STDR, which by default is a screen. So what I do is I say pretty much I don't want my STDR to go to the default, which is a screen. Okay. Instead, I want it to be redirected to a file, and this file is going to be, in this case, sort.log. Okay. So any error will go into that file. Very good. So this is really the analog of what we have done here with a greater than and 1 greater than, but now we do it with 2 greater than to redirect this specific output. Now it's possible to do both, obviously. Okay, so let me clean up things a bit here. I'm going to remove that sort.log. And what I'm going to do is I'm going to make a little folder so that we don't see a bunch of files every time we do something. Alright, what I'm going to do now is I'm going to combine both redirections. So sort-l, okay, invalid, and then a sort that is actually a valid sort. And I'm going to try to run both using the 2 redirections at the same time. So let's start with sort-l. standard error needs to be redirected to a file. Let's call it sort.log. Let's call it sort.error. And then the standard output, okay, is going to be redirected to a file that I will call sort.out. Sort.out. So I'm doing both redirection right now. Here's what happened. I used sort-l, so we know that it didn't work, okay? So if I look at the file that have been created, 2 files have been created. I look at the error file, I see something in there. I look at the output file, I don't see anything in there, okay? So that's exactly what we expected. Now, let's try to not use an option that's going to lead to an error. What happens? Well, I don't see anything displayed. But that's normal because I redirect my my output to sort.out, my standard output. We know that sort anyway will not display anything. It's just waiting for me to type things. So 1, 2, 3, 4, and 5. Okay. Now I want to notify sort that I'm done providing input. So Control D. Sort terminated, but we don't see anything on the screen. There's nothing that was displayed. So, as expected, the data went into one of those files. Which one? Well, if I cat sort.err, there's nothing in it. Whatever was in there previously, in my previous experiment, got overwritten. Okay? So this is something I have not mentioned until now, but every time you use this redirection operator, whether it is greater than, 1 greater than, or 2 greater than, what you mean is connect my standard input, my standard output of my standard error to a file, and if that file doesn't happen to exist, just create it. If it happens to already exist, replace its contents by the new content. So that's exactly what's been going on there. So sort.err is empty. Sort.out contains the sorted output that sort would have otherwise displayed on the screen. So an interesting thing to look at right now, and we're going to repeat those 2 experiments, okay? The experiment with sort causing an error, the experiment with sort working as intended. What is interesting is, does the order of my redirection matter? And we're going to see that in this case, it does not. Now, we're going to have a follow-up video where we're going to discuss other types of redirections, and when we explore those other types of redirection, then it's going to matter. But for now, the order doesn't matter, so I'm going to try to prove that to you, right? I'm going to take this here, and I'm going to, not this actually, so I'm going to leave sort alone. I'm going to redirect 1 to standard output to sort.out, and 2 to sort.err, okay? So let's repeat our 2 experiments. The first one is I'm using an option that's not allowed. What happens? The files are there. Sort.err, there we go. So the error is there. Sort.out, well, but there was no input asked. You know, the program stopped immediately, so there was no output created either. First experiment, exactly same behavior. Second one. So I'm using now sorry. I'm using now sort as it's meant to be used without an erroneous option. I'm typing 1, 2, 3, 4, 5. Okay, Control D. I'm done with the input. That looks like exactly what happened before. Okay, so that's good news. Let's do cat sort.err. No mistake, no error. Cat sort.out. Here is our output. So nothing new. It behaved exactly the same way it behaved before, therefore changing the order of those redirections. These were totally independent redirections. The order didn't matter a bit. Okay, let's go to the next redirection we're going to discuss, and we're still talking here about simple redirections. So we talked about redirecting STDOUT. We talked about redirecting STDERR. Okay. So as a matter of fact, here we used the sort.err and sort.out. Okay. The only one we haven't talked about yet is actually this one here, STDIN. Right? So there is a way to redirect STDIN as well, because right now the sort command has been using the keyboard, right, as its source of input. It let me input the data that I wanted to provide to the sort program. Now, if I use lesser than, this is a rather wonky lesser than sign. I'm going to redo that. But if we use lesser than, it changes the direction of things. This time we don't want to take a command, okay, and redirect its output. We want to actually feed to a command. So you can see the sign is like this, that suggests an arrow that goes this way. So we take a file and we feed it to the command like so. Okay, so that's a way to remember how it goes. And this is also a way to say, you know, I want to feed some data from a file to the file descriptor 0 of my program. So I would type sort greater than name of a file, or sort 0 greater than the name of a file. And please note that there is no space between the number here and the sign, right? Whichever you are looking at, the number and the sign are like stuck to one another. If you put a space in between, this is going to mean something completely different, so don't do that. So let's try it. How can we do this? Well, sort, you know, this is the traditional example we have been using, Control D, and then we're done. So now we're going to try to replace this by something like this. Sort, to keep up with our convention, sort.in. Okay, that's what I would like to do. To be able to do that, I need a file sort.in. So I'm going to take care of that. I'm going to say, here's a funny way to create a file, by the way. I'm going to say cat. So cat is supposed to display whatever you type, right, on the output. I type 2, I type 3, it displays 3. Control D to finish. So I like the part where cat reads what I have to say, but I don't like the part where it displays it on the screen. So I'm going to say to cat, please redirect your standard output to the file sort.in. And then I can type 1. You can see there is no display back on the screen. 2, 3, 4, 5. Okay? And Control D to mean I'm done with my input. So cat functions exactly the same way. But the same way cat can display back on the screen, it can display back in the file sort.in, it can display back in any file I want, depending on how I redirect its output. Okay, so that's one of the funny thing about redirection, is that we can use the same command to do different things on different files, blah blah blah. And you're going to see as we explore piping and other topics that it goes farther than this. Okay, but what matters for now for us is that now we have in sort.in, sorry about that. We have in sort.in all the data that we used to type by hand over and over and over. So let's go back to sort. What if I do this? What if I do sort lesser than, which means redirect a file to my standard input, and the file is sort.in. Well, I didn't type anything. Why? Well, all the data was provided for me. When we reach the end of the file, it does exactly the same thing than when I do Control D on the keyboard. Control D is actually a way to generate on the terminal an end of file signal, so not signal, character. So that shows you that those tools are really meant to work with the keyboard as source of input, the same way as they work with a file, a text file as source of input. So what we have, on the other hand, displayed by sort is 5, 4, 1, 3, 2, which is the output it would display anyway with that kind of data. Okay, if I do a mistake and I use an option that's not valid, the input is still provided to sort, but sort disregards it because the invalid option -l caused it to stop immediately and display that error message on STDOUT. So that means that I could now combine, I have an easy way, you know, to feed data file, huge data files, to commands, to arbitrary commands without having to retype things. But I can also combine all of this with what we have seen. Before I do this, I almost forgot, let me confirm that, you know, if I put 0 lesser than, everything is still working. So the error message scenario works. The scenario where everything goes well works as well. So the syntax are completely interchangeable. Now let's move on to what I was about to do, which is combine this with what we have done before, which is standard error goes to sort.err, and output, which I'm going to abbreviate like that, goes to sort.out. So I'm combining everything we have seen so far. So when I run this, nothing happens anymore. It's no longer interactive. It doesn't read from the keyboard. It doesn't display on the screen. Okay, everything is happening in the background in terms of files. So what do I have exactly? Well, you know what we have in sort.in already. Okay, that's our data file. That's our input. What happened with the error? The error, in this case, everything worked well, so there's nothing there. What happened with the output? Well, in this case, the output was computed because there was no error, and the output is what you would expect to be displayed on the screen. So sort is a very interesting command because it allows us to illustrate, what happens with the free base redirection of STDIN with the second type of redirection that we studied, which is a lesser than redirection of STDOUT and STDERR, which work with the second type of redirection that the first type, sorry, of redirection that we studied, which is a greater than sign. Okay, and with those simple tools, sorry. So to sum up, we have lesser than, which is equal to des. Okay, we have greater than, which is the same thing as des, and we have 2 greater than, which is also output redirection. So we have 2 types of redirection of input, redirection of output. This one works with STDIN, this one works with STDOUT, this one works also with STD output, but this time STDERR, which is the error output. Okay, with those simple the simple syntax. So there's like 1, 2, 3, 4, 5 different syntax to learn here. You can take a command and you can say to that command, well, I'm going to redirect your STDIN, I'm going to redirect your STDOUT, I'm going to redirect your STDERR, and each time provide a file. Okay, so you can do that separately, or you can combine, by saying, here's my command. Okay, this is what's going to represent my command, and I want you to redirect with this file, and I want you to redirect out with this file, and I want you to redirect my error to this file. Okay, and these are the 3 things that we have covered. I'm going to add one more little thing, tiny little thing, but that's going to come in handy in the next videos as well. There's a special file called /dev/null. And this is a file that, if you try to cat it to display its content, there's nothing. If you would try to take the sort command that we have been using, and instead of putting the output here in sort.out, you put it in /dev/null, here's what would happen. Okay, so you remember from des command, I took des data here in sort.in. Alright, there was no error, so sort.error was empty. And then I used to have my output in sort.out. Well, I put it in /dev/null, so it should be there, right? No. /dev/null is the, if you will, the black hole pseudo file of Unix and Linux systems. Everything that goes in disappears. Everything that you're trying to read, nothing comes out. So it's really, for all intent and purpose, our little, systems black hole there. So if you want to get rid of an output, you can do so like this, okay, by redirecting to /dev/null. So it's not really great to get rid of an output that represents some result, the result of a computation. So we certainly, we most likely, I should say, don't want to get out of our output, don't want to get rid of our output, but we might want to get rid of the error output, so that we don't have to redirect it to a file, we don't have to look at it on the screen, we can ignore it totally. So if I do this, the same thing is going to happen here. This is the data that went in. This time there is no sort.err generated, but I have still my sort.out. Okay, so this is the data that came out. But everything that was error message disappeared, if there was any. So in this example there was no error message, but if I do this, my option that doesn't exist, right? Again, I can take a look at sort.in is still the same data. I can take a look at sort.out. Sort.out was not produced because there was a mistake, but the error message disappeared completely. So sometimes it's useful to redirect either the standard output or the standard error output to get rid of pesky little debugging message, especially when you're still developing an application, to make sure that they don't display, like in your console, in your user console, as you are trying to test out things, for example. And that's what I wanted to add to this this first video here. So we have all of those elements of syntax here, how to use them separately, how to combine them, and we have this /dev/null file, which is interesting, which allows us to provide no input, for example, or to just trash the output from STDOUT or STDERR. And that's going to wrap it up for this this video on simple redirection. Thank you for watching.